Welcome. Today's class is completely and thoroughly understanding centroid G for a trapezium. This is very, very important because in structural engineering, so many places you get trapezoidal loading. For beams, you may not get much, especially suppose you consider retaining wall, their pressure distribution will be trapezoidal. Or if you consider foundation slab, the soil pressure from foundation slab will be trapezoidal. Because we consider trapezoidal, there will be some small curvature will be there that you are not considering. And also, even for examination also, so many or in structural analysis, when you go to moment area method, conjugate beam method, etc., their bending moment diagram will come. You require area and centroid for that diagram. Many times you get trapezium there. So, understanding centroid for trapezium is very important. Last class we derived the equation. Okay, now first I will do one thing. I will explain everything by words. See, I slightly changed the pattern. I told last time summary of all triangles and trapezium will come. It will come a little later. But I decided completely clear trapezium. So later I will not talk about trapezium much. I will tell go back to that class. Okay. For a trapezium there are two parallel sides. That is a basic definition. See, two parallel sides are there. It can be either this way or this way. Don't by heart horizontal vertical. There are two parallel sides. Say B1 and B2. This for easy understanding can be taken as the base. See here. This is parallel to this one. See, you can tell this is a base for trapezium, base for trapezium. Invert it or see. Now, these are the parallel sides. You stand from here. This can be taken base. This you cannot take base. So there are two parallel sides which for easy understanding you can take base. So right now my symbol is B1 and B2. Later when you go to structural engineering, it will not be B1, B2. It will be intensity of load. That I will tell later. And H is the perpendicular distance between the two parallel sides. Between the two parallel sides, the perpendicular distance is H. Or this for easy understanding can be taken as height. See here. See once again. Base, height, or see. Base, height, that way. You stand from here, this will become height, turn it. Now, the standard expression for distance of centroid G is from any one of the parallel sides. Any one of the parallel sides. That is from B1 or B2. Or you can tell that is R from base, any base. You can take either B1 base or B2 base. And remember, if the base is like this way distance, so this distance is always along the perpendicular distance between the parallel side. So that is along H. So distance from parallel side, but the distance is along the perpendicular distance. That is, see here, I will explain here. See, suppose your trapezium is like this. See here. You make a note for good health, or your trapezium is like this. See here. These are the parallel sides. This is the height. I will take one of them B1, other B2 here. These are the parallel sides. One of them I will take B1, B2. This will become height. Here, the standard formula for centroid is either from B1 or from B2 along H, that is this way. See, this way is standard formula. This way, not this way. Whereas here, it is either from B1 or from B2 means the distance is this way. Either from here to there or from there to here. Double arrow mark I will tell. You can take either this way or this way, or I can make one thing, see, to make more clear. Either this way or this way. Here, either this way or this way. Okay. Now, along the edge. Now, I will not tell this again and again. Then, distance, okay. Then, see, correctly, I will first give by words to make more clear. One small note. So many places you require area of the trapezium. You don't have to bother about division all. Standard formula for area of trapezium is sum of the parallel sides divided by 2, that is called average. Divided by 2 for area, dividing number is 2, remember, into distance between the parallel sides. That is the formula for area. Or area term has got, see, numerator, actually parallel side into distance, or sum of the parallel sides by 2 into distance between parallel sides. Okay. And most important, very, very important is distance of centroid from any one of the parallel side. I already told you, measure standard formula is from any one of the parallel sides, that is either from B1 or from B2, but note, either from B1 this way or from B2 this way, if this is these are the parallel sides, or either from this side or that side if parallel sides are this way. But note, this distance is this, you write here, this distance of centroid, this is along H, that is along the perpendicular distance between. Measurement from horizontal means distance is vertical. Measure from vertical is distance is horizontal. That formula is that parallel side, you write here, that parallel side means that is from which parallel side you are finding distance. Or actually that much is not required, because see, once I wrote from any one of the parallel side means in the mind one parallel side will come. So once you decide distance of centroid from which parallel side you want, formula is that parallel side plus twice. I don't call 2, I tell twice. Means 2 times. Don't tell twice times. 2 times that parallel side plus 2 times of other parallel side divided by, again, sum of the parallel sides. Divided by sum of the parallel sides multiplied by distance between the parallel sides. But remember, when you want area, divide by 2, but when you want centroid, divide by 3. Or you can make a note here, see, sum of the parallel side is linear as per geometry. In a bending moment diagram, they are not linear because they are intensity. Right now I am talking about what? Plane figure area. Distance also is linear. So linear into linear is linear square. But here distance is only linear. See, this is linear. And this term is ratio. See, there is no unit for this one. This term is a ratio. See, why? Because, see here, why ratio? This is a ratio and no unit, because it is distance plus distance divided by distance plus distance. Numerator is distance, denominator also distance. So this is only ratio. Finally, in what unit you write this one, that unit you will get distance of centroid. So formula is, once you decide from which I started training slightly, I have to pause now. Once you decide from which parallel side you want distance of centroid, it is along the height or h. Formula is that parallel side plus twice of other parallel side divided by sum of the 2 parallel sides, then outside multiplied by distance between the two parallel sides, heavy rain now, divide by 3. Okay, I will pause the recording. Rain became suddenly heavy. Now we will continue. Something I will tell, write everything if you really want to learn. This I always insist. Should not ignore anything. What all I tell, everything you are try to understand. See, I will write just now. I gave expression for locating centroid for a trapezium by words, thoroughly explained. And I told one more thing. The standard expression is only for locating centroid along the height or along from one of the parallel sides, and measurement is along the perpendicular distance between the two parallel sides. Everything is so clearly explained. Now, for a thorough understanding, see, this trapezium is a very powerful expression for trapezium is very powerful in so many chapters later. So, now see, also one important note, I forgot to write, I put a dot here. You should write in the beginning only. See, I will do one thing, I will take B1 and B2 as the parallel sides. This I told you last time. B1, B2, parallel sides, and H is the distance, perpendicular distance between the two parallel sides. Now, important note, right in the beginning, whether B1 more than B2 or B2 more than B1, it does not matter when we apply standard expression. See here, whether B1 is more or B2 more, I have taken B1 more here, okay. B1 more or B2 more does not matter, because in the equation, what comes when you measure from here, this side plus twice of that side will come. So B1 more or B2 more does not matter. But it matters when you locate centroid this way. See, that is not along the perpendicular. See, this is the perpendicular, H. These are the two parallel sides. Standard expression is for this distance, not for this distance. Okay, now, to thoroughly understand, see, B1, B2, distance between them H, area equal to, I will tell now only. See, one more sketch is there here. B1, B2, distance between them is H. B1, B2, distance between them is H. Some will tell, why 3 sketches? See, here, it goes this way. Offset left side, offset right side. And here, offset only on left side. Here, offset only on right side. And all these sketches, your parallel sides are, I written horizontal. See, horizontal. So the perpendicular distance is vertical. That's why 3 sketches. Second round, I will put this way. See, I am going to cover each and everything. Now, one thing important, I won't waste time. I told area. See, our purpose is to locate centroid. But when you calculate or when you find resultant load and moment of the load later for loading in the form of trapezium or trapezoidal loading, total load is equal to area and line of action is to centroid. So you require area. So I wrote area also. See, whatever you write, area is sum of the two parallel sides, B1 plus B2, divided by 2 into distance between them. See, I wrote area here, I wrote area here, I wrote area here. Now, see, to understand, right mark means yes, standard expression available. I have written here, for locating centroid, okay. Standard expression available, understood. For locating centroid G. Question mark means no, standard expression is not available. Then what to do? Divide into parts and get it. Next class, today's is part 1. Next class, I will do that one. So today, I will apply only standard expressions. Okay, start. First sketch here, see. B1, B2, H. B1, B2 are the two parallel sides. H, distance between them. B1, B2 are the two parallel sides. Distance H. So, in all these three cases, your parallel sides are horizontal. And distance between the two parallel sides, that is H, is vertical. So, standard expression for locating centroid is available along the height. So, this way available, once you know from here, see, once you get this distance, you can get easily from other side, but formula, you can see, send CG somewhere here. See, I am locating CG from the base, this way or this way. Here also, see, centroid this way or this way. Centroid this way or this way. For this one, standard formula is available. I write the formula. Formula is, see, suppose you want centroidal distance from this side B1. I told, if you want from this side, put the finger here. Then that side B1 plus twice of other side, other parallel side. B1 plus, okay, 2 times B2 divided by sum of the two parallel sides, B1 plus B2, into distance between the two parallel sides, H, divided by 3. That is the expression for centroid. Right mark means yes, standard expression available. Same way, if you want from this side, see, put the finger here. Start that side first, B2 plus twice of the other parallel side, twice of B1, divided by that side plus this side. So easy, see, into distance between the two parallel sides divided by 3. And now, question mark means standard expression not available. See, this way, see, this is X bar, this is actually Y bar, remember. In all these cases, what you are writing today is Y bar. You can make a note. That is Y bar distance. X, you can write all here. Today's, in all these sketches, you make a note. Y bar expression is there. X bar expression is not there. See, because this way, see, there is no parallel side here. See, this way you can apply standard formula. If the parallel sides are like this, no, you can't apply. So, question mark means now no standard expression. So, from here if you want centroid, no, we don't know. From here we don't. Right now we don't know, or standard expression is not there. Then what to do? Divide into parts and get it. Next class, I will do that one. Okay, start. Come here. Again, waste of, I already wrote it here. See, from here if you want. B1 plus twice of B2 divided by B1 plus B2 into H by 3. If you want from there, same thing, already I explained. B2 plus twice of B1 divided by B2 plus B1 into H by 3. Okay, I wrote there, right, area. This also same. It does not matter what, whether there is a left projection this side, or projection on one side is there, or this side is there, or whether B1 is more than B2, or B2 more than B1, does not matter. But one thing, centroid will be always near to the side which is little bigger. So here, centroid will be slightly, see, it is near to B1. In all these three cases, it is near to B1. Anyway, when you calculate, you will get the answer. So this will finish one round for parallel side like this. To make the concept completely clear, I will now write once again same 3 sketches. This time I will take parallel side like this. And I will not explain this much. Okay, I will prepare that one. That way parallel side. Now continue, make a note. You can make a note. Extra note you can make. Last three sketches I have given is parallel sides are horizontal. Perpendicular distance is vertical, h. So, standard formula is always from one of the parallel sides or it is along the height h. So, last question, the standard expression was for y bar, x bar not available. But this time, see, two parallel sides are vertical. See, vertical, vertical. See, once again, see here. I put B1 lesser, B2 more. I put B1 lesser, B2 more. Here I made B1 more, B2 lesser. It does not matter. And also, whether both side projections are there, or only one side projection is there, or only one side projection is there, that does not matter. And how much projection, that also does not matter. But it matters when you find this centroidal distance. See, when you find this distance, it matters. See, now, all these three cases, see, parallel sides, h, parallel sides, h, parallel sides, h. Expression for standard expression for locating centroid is always from one of the parallel sides, this way, or along h. So this time, this way, right, 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 right means standard expression available. But this way, either here or there, wherever you want, you can mark here also. This way, or this way, no standard expression, because where is the height this way? But how to get it? It comes in next part 2, where I will solve the questions. So right now, we are discussing standard expression. Okay, now I already wrote here, no time waste required. See here, B1 plus twice of B2 divided by B1 plus B2 into h by 3 from here, B2 plus twice of B1 divided by B2 plus B1 into h by 3. Area B1 plus B2 by 2 into h. See, B1 plus from here, B1 plus twice of B2. Here, B2 plus twice of B1. Other is same. B1 plus twice of B2. This way. This way, B2 plus twice of B1. It is explained many times, sufficient. Therefore, that's all. Make a note. And last time question or last three sketches, you write standard expression was for y bar. But this time, standard expression is for x bar. You make a note. You write it. In the previous sketch, you write all these three sketches, standard expression for y bar. You write here all these three sketches, standard expression for x bar. Okay, now I will go to numerical example for all the 6 cases. Then I will tell you what I will do in the part 2. We are in part 1 now. Now, 6 examples numerical so that you get full control on location of centroid for a trapezium using standard expression. Class, you should write. When you have to, see, I have dictated something here. When you have to locate centroid for a lamina, say for trapezium, you need both x bar and y bar. But standard expression is only for one of them, either for x bar or for y bar, depending on how are the parallel sides. See here, I already told, if the parallel sides are this way, see, first 3 examples, 1, 2, 3, parallel sides are this way, horizontal. So this is the height. Standard expression is this way, measured from parallel side. So for all these 3 examples, you write a standard expression available for vertical distance or distance along the height. I not give the height here. I forgot to give the height only. Okay. Some height I will give. Some height. Okay, here. I forgot. Some height, whatever I want I can give. 200, 150, 150. Okay, 150 over. Anyway, when I calculate, I can make out. Right here. Other distance, today we will not do it because today our work is only using standard expression. Then, class, what about other distance? Once I finish the 6 examples, first 3 examples for y bar, because these are the parallel sides. Next 3 examples, you write here now. Example 4, example 5, example 6 will be this way. The 2 parallel sides will be vertical. See here, parallel horizontal, this way. Then perpendicular distance is horizontal. So when you measure from parallel side, you will get x bar. So these 3 questions, first 3 examples, standard expression is for y bar, and next 3 examples, I will write it after I rub the board. You write now only, because why? You copy all the questions. See here, space problem. You do one thing, you copy all the 6. Later, I am giving remaining 3. Next 3 examples, it is for x bar. Okay, then further. Once these 6 examples are over, part 1 is over, part 2 will be once again locating centroid for same 6 questions. There, we will not apply standard expression. We will do by summation, by dividing into parts. But remember, there, one of the answer is missing here. Other answer is you already got by standard expression. So, suppose this question later, if I find y bar, it should match with what I got today. But x bar, some value will come. So that is for next class, I will maintain the same 3 questions. So that, see, for each question, either x bar or y bar, one of them is you can get by standard expression. But there, both we will do by first principles. We will not use standard expression. Then I'll give a note there. See, actually, we found by A1, Y1, A2, Y2, A3, Y3, actually not required. You can directly apply standard formula like earlier. See, today we got this answer. Earlier, see, same answer. Okay. Right here. For all 6 examples, question is, for all 6 examples, locate centroid G using standard expression. All dimensions in millimeter. Now make a note. When you start solving, we will locate centroid using standard expression that is only in one direction. Other, we will put a question mark today. Other, we will put a question mark. Okay. This is also clear. I will start solving one by one now in order. Okay. I'll start. No question of pausing. Now I will not explain too much. Okay, start. Example 1. Example 1. Big sketch I'll put here. Example 1. Or I'll do one thing. I will write the sketches to save the time. Because to save the time, I'll pause. Why should I waste time unnecessary writing everything again and again? I'll pause. Start now. I written 3 questions here. I told all dimensions are in millimeter. I told 200, 500, 150. See, this offset is 120. So if you want this offset, it is 500 minus 120 minus 200. But actually, our y bar, this way is standard formula. This offset 120 does not matter here. And also I told this offset does not matter. And here, see, here, both side projections, right side projection, left side projection. See here, one of them, bottom I made more, top lesser. Here say, but here I made bottom lesser, top more. I told it does not matter. Among the 2 parallel sides, which is more, which is lesser, does not matter when you locate centroid by standard expression. Okay, start now. neat sketch 200, but I wrote that 120. See, for right here, for standard expressions today, you make a note here. This 120 is not required. So start 200, 500, 150. See, these are the two parallel sides. So this way CG, along the height, you can get CG. Yes, centroid G. See, from here if you want, it is 500 plus twice of 200 divided by 500 plus 200 into 150 by 3. I got 64.286. See, once you get this one, 64.286, this distance directly you can get from 150, subtract that one. But anyway, I calculated once again from that side. 200 plus twice of 500 divided by 200 plus 500, see, into 150 by 3, I got 85.714. If you add these two, check, it should come 150. It came. Just for information, area, sum of the two parallel sides divided by 2 into 150 area in millimeter square. And this is this way CG. This way CG, see, this distance, we don't know, no standard expression. So this way CG will be in part 2. In part 2, there, this also I will do once again by summation principle, but you will get the same answer. See, when I solve this question in second round, part 2, I will not use standard expression. I will divide into parts. Then my guarantee, this you will get. This you will get same answer. I will tell at that time, go back and see the answer. Now, for thorough understanding, it is better if you write 3 sketches in a big page, left hand side, all these 3 solutions in the same page, right hand side, one below other one, adjust it here. So that way if you do, you can compare very easily. Okay, now I will go to example 2. Example 2 is, I start fast here, no pausing. Example 2 is, here see, 50, 40, little bigger I can write, my space is there. 50, 40 and then 80. All in millimeter I told, okay. So I write here, this is 50, this marking is not required, okay, mark it here, 50 this way. This is 80. Later, if you want this projection, it will be 30. And height, see, this way, is 40. Again remember, I know centroid is slightly below and from center, little this side. That you never bother. Today's class, this is centroid G. You write here, these are the two parallel sides. Our standard formula is from one of the parallel side, so along 40 you can get. So this you will get by standard expression. See, standard expression. Last time I forgot to put right mark there. Standard expression. Whereas, if you want this distance or this distance, question mark in part 2. Okay, start from here. If from here, 80 plus C, if you want from here, your finger is here now. First that side, 80 plus, see, arrow mark, okay. 80 plus twice of 50 divided by 80 plus 50 into 40 by 3. 40 by 3, get the answer. Then, if you want from there, actually once you get this answer, from 40 you subtract, you get the answer. But still, we will do it from that side. 50 plus twice of 80, this all explained so many times now, divided by 50 plus 80 into 40 by 3. Get the answer. I am not saying that I don't have to look at there. 80 plus twice of 50 divided by 80 plus 50 into 40 divided by 3. 18.462. I am writing for third decimal accuracy. 18.462 millimeter, because this is millimeter all. That distance has to come minus 40. 21.538. This has to come 21.538 millimeter. Anyway, no cheating. I will calculate. See, 50 plus twice of, as a check, 80 divided by 50 plus 80 into 40 divided by 3 is 21.538. Perfectly tallying. Okay, done. Next, example 3. Now one more round is there. Over. You make all these 3 in a single page. You write the 3 questions on the left hand side of the page. The small you write. Right side have more space and write here. Example 3. See, this time see 120 bigger. Which bigger, which smaller does not matter. 60 and 75. Okay. This is 120 and this is 60. These are the 2 parallel sides. Other is 75. I am not writing ABCD all. Next time I write ABCD. Okay, now for this one, second question, I forgot to get the area. Okay. Make a note here. Did I get it? No, I think actually not required. 50 plus 80 divided by 2 into 40. You make a note. Area for this one, I forgot to write last time. Area equal to 50 plus 80 divided by 2 into 40 equal to 2600 mm square. If I am not written, you add it there. Add it. For second question, just now I solved. Here, I will first do area. Area equal to 75 plus 120. See, I told you, which is smaller, which is bigger does not matter. Divide by 2 into 60. 75 plus 120 divided by 2 into 60 is 5850. Area is just a byproduct. And now, centroid, center here, little this side. I am expecting it to come here. Okay, don't worry. G. See, these are the 2 parallel sides. Therefore, this way CG distance or this way CG distance, yes, there is formula. Whereas, if you want this way, see, suppose you want, here, see, what is this distance and what is from extreme end, see, suppose here, what is this distance, question mark in part 2. Question mark in part 2, not now. Because why? Part 2 is both x bar, y bar. So this will be, start here, from here. From here, if you want CG from here, see, 75 plus twice of 120 divided by 75 plus 120 into 60 by 3. It will come 75 plus twice of 120 divided by 75 plus 120 into 60 divided by 3. 32.308, third decimal. It came 32.307769. I am rounding off to 32.308. 32.308. I know that CG will come more than 30. Now, this distance has to come minus 60. 27.692. It has to come 27.692, but I will calculate millimeter. Why? Application means application. Or if you want from that side, the formula is from here 120 plus twice of 75 divided by 120 plus 75 into 60 by 3. Okay, we will check it. 120 plus twice of 75 divided by 120 plus 75 into 60 divided by 3 is 27.692. Okay, done. These 3 cases are over. Now I will do example 456. to save the time, what I will do is, see, now I don't have to keep on telling same thing again and again, again and again. So, little smaller, I will put the 3 sketches here, and in the available space, I will write solution, then briefly explain. That's much better. Because by same thing, only thing is what? Next 3 sketches, parallel sides are this way. So, X bar you will get. This is also already explained. Now, much explanation is not required, I think, because you are engineers. Make a note. In these 3, 4, 5, 6 examples, the 2 parallel sides are vertical. So, perpendicular distance between them is horizontal. So, standard formula is for location of CG from one of the parallel sides. See, this way. Between the parallel side distance. So, in these 3 questions, standard expression is for X bar either from here or from here, and no standard expression for Y bar. Y bar what to do? Y bar in part 2. Over. Now, neat sketch are written. See here, this 30 is not required for us today, but it is required next time when I find Y bar I require it. Now I will do one thing now. Instead of wasting time, I will tell here only. See, from here, see there. From here, 100 plus twice of 170 divided by 100 plus 170 into 45 by 3. From here, 170 plus twice of 100 divided by 170 plus 100 into 45 by 3. Actually I wrote everything there. From here, 80 plus twice of 150 divided by 80 plus 150 into 130 by 3. From here, 150 plus twice of 80 divided by 150 plus 80 into 130 by 3. From here, 140 plus twice of 90 by 140 plus 90 into 75 by 3. 90 plus twice of 140 divided by 90 plus 140 into 75 by 3. Of course, when you get this X bar and other side X bar, if you add those two, you should get 45. If you add these 2 X bars, you should get total 130. Here, if you add those two, you should 75. That's a check. Vertical distance here we can't do. Okay, over. This is end of your part 1 of thorough understanding of the trapezium. Part 2 is same 6 questions I will solve. Maybe among the 3, 1 I will solve. These 2 I will give exercise for you. Sketches I will write. There, we will actually there also in one direction you can locate centroid direct by formula. We will not do it. In both directions we will go for summation. We will find X bar, A1, X1, A2, X2, etc. divided by total area, Y bar, A1, Y1, A2, Y2, etc. But then one of that answer is already here. In the first 3 questions, Y bar answer is already over. You can either do by that way, I will write there, or remember, you can do directly by standard expression. So next class is more powerful. This is very, very powerful because usually in structural engineering, when trapezoidal load comes, remember, you always require distance of centroid along the base or one of the parallel sides. So in all the bending moment calculation, standard expression is useful. Other centroid distance is not required. But anyway, we will complete. So now, correctly go through. Next round will be same 6 question. I will make a note. I will not remember this answer. I will tell you. You go back earlier and check the answer. It should have come same. Somewhere in the corner, I made a note of these sketches there, so that I may forget it. Some small corner, small cut, I made a note. Okay. That you cannot see. I covered it. Okay. Thank you. We will meet next time.